Hi, my name is Michael, and today we're going to be discussing Thevenin equivalence. This is a means by which we can take a complicated circuit model and turn it into something that's much simpler and easier for us to analyze any of the parameters that can include open voltage, equivalent resistance, and short currents. So here we have a complex circuit, and you'll note that this circuit includes a voltage source, a current source, two resistors, and this VAB point. This VAB point is going to be the first step in determining our Thevenin equivalent because we've now identified our vantage point, the perspective by which we want to look at this complex circuit. Why is this important? Because point A is going to be our inlet, where we're going to be following how the circuit is functioning, going through here to these two resistors in parallel, and B is going to be connected to our ground. So we know that this is going to be our out point. So what's the first thing that we're going to do? We're going to take our voltage source and turn it into just a simple wire. So you want to remember that it's important when we take this perspective VAB and we're looking through our resistors that we're going to take this voltage source and this is always going to become a wire. On the other hand, when you have a current source, you'll note that it becomes an open circuit. And this is important because we're going to compare the circuit from these two different perspectives, again, always looking from the point VAB. So the first thing that we have to do is understand how the circuit is functioning through these two resistors with respect to our voltage source. So since R2 is across from our voltage source, or the wire that replaced our voltage source, we're going to put R2 on the top of this equation. And then, as we've done in other circuit analysis, we're going to put the sum of these resistors here, multiplying this all by our original voltage source. This is going to be the first half of the superposition principle by which we can calculate the Thevenin voltage. The second portion is going to be with respect to the current source that used to be here. We know that these two resistors are in parallel, and as we've learned before, we always want to do the product over the sum. So what is that going to look like? That's going to be R1 times R2 over R1 plus R2. And instead of multiplying it by the voltage source like we did before, we're going to multiply this by the current source. Ultimately, the combination of these two is going to result in our Thevenin voltage. Now, another element that we have to calculate in addition to our Thevenin voltage, which is the voltage across our perspective point VAB, is our equivalent resistance. Now, we've already done that without realizing it. Our Thevenin circuit resistance equivalent is going to be, again, the product over the sum. So this is going to be R1 multiplied by R2 over the sum of those two elements. And that's going to result in a simplified model with just a single resistor. So now we've calculated two of the three elements that are resulting in this simplified model. We have our Thevenin voltage, instead of having both a voltage source and a current source in our original model, and we have our equivalent resistance. So now we can much more easily see how we're going to look at the circuit, and remember that we were originally taking this RL element as our vantage point, so we want to make sure to include that. Ultimately, we've now taken what was a complicated circuit with both a current and voltage source, two resistors and this vantage point, and turned it into a much easier circuit to calculate our current. Remember that we use Ohm's law to analyze these. We have the Thevenin voltage, we have the short current, and we have the equivalent resistance. So if at any time you have two of the three elements calculated, you can remember that you can put, as in this example, the Thevenin voltage over our equivalent resistance to get our short current. Through this exercise and example, we've taken a complicated circuit, as shown through the steps, and simplified it to a simpler model by which we can understand these parameters and what's actually happening in the circuit.